Hi, I'm Philip Odango, and today in Cosplay Central, today we're going to be talking about 3D printing for cosplay. And I'm here today with Chase Carlyle of RPM 3D Printing.
Hi, I'm the owner of RPM 3D Printing. I print a lot of different things, cosplay, functional items, prosthetics.
So 3D printing has become a large part of kind of the cosplay making experience. What have you seen in the evolution of 3D printing and making it more accessible for makers?
I think with a lot of the different softwares out there, it's getting easier for cosplayers to design their own pieces and props to just be able to make whatever they want, just tiny little things to entire costumes. So there's a lot of utility to it.
Whatever you can imagine, you can model it and make it and create it.
That's our motto.
And there's actually different types of 3D printing, right?
Yep. We've got fused deposition modeling, which is like this. The printers behind me are all FDM printers. They use rolls of filament, plastic spools, like giant 2-pound weed whacker lines that just go into the printer. The printer melts them and lays them down layer by layer by layer. And there's other types as well. There's SLA and SLS printing, which is the resin printing. You can see here. These are resin printed. They're, the accuracy you get with resin printing is absolutely amazing. The only downside is, depending on the resins, it might be a little brittle. But another great example of FDM printing, this helmet was FDM printed in PLA plastic.
And so we're using a lot of kind of acronyms here,
Yep.
right? So can you tell us a little bit more what those acronyms mean?
Polylactic acid is PLA. It's the bread and butter of 3D printing. It's the cheapest filament you can use. It's the easiest to print with. Almost every 3D printer is set up to use PLA filament. And it's got its drawbacks. It's got strengths, as in literally its strengths. It's very rigid material. The downsides are it doesn't do too well to heat. So if you leave this in your car on a summer day, it will implode. You can put it in boiling water and bend the parts. So it's also another way when you think about cosplay. If you want to print a part and then boil it, put it in there, and you can bend it to the shapes you want. And after it cools down, it just will keep its shape.
And there's also PETG.
PETG is another type of plastic. It's the kind water bottles are made out of. This helmet here was printed in PETG. It's got a little bit of wobble to it. It's a lot more flexible, and it's prone to bending more before it'll break. So there's just different plastics for different applications. I guess the downside is a lot of printers straight off the line aren't exactly built to start printing with this. There's another one, ABS, which is a petroleum-based plastic. It's the same stuff Legos are made out of, but it's a lot harder than PLA. It does better with heat than PLA. It's just you need different temperatures, and it can be a little finicky to print with.
What are some resources that are available out there if you just want to learn how to get started in 3D printing?
So there's two different sides of it. There's 3D printing and there's 3D modeling. 3D printing, there's a couple different resources out there that are free and available to the public. Google has a free one called Google SketchUp. So if you know the designs you want, you can, it's just like starting with a drawing, and you don't even have to be really good at drawing. You can just draw line segments, and you can come up with some amazing things. Tinkercad's amazing. It's a very easy tool to use. It's run by Autodesk, the same people that do Fusion 360. Tinkercad, Google SketchUp are definitely the first stop as far as getting an understanding for how 3D models interact with each other and design. Blender is really good for doing organic modeling. If you had an extravagant headdress, some armor that has a lot of bends, something that can't be measured, Blender is the software you'd want to use for that, it's free to use.
Now, there's actually resources out there of existing models, right?
Absolutely. So say if you don't want to design something or you want to use someone else's design, there's websites that are just repositories full of different 3D models that are free to download. Thingiverse.com is an amazing resource. If you make something amazing, you can upload it and other people can use it. Thingiverse is one. Cults 3D is another website that has 3D models, and there's search engines for 3D models. Sometimes people have already developed something that you want, and it might be easier just to use their model.
And so there's actually a lot of evolution. We're talking about the different types of filaments earlier.
PLA, PETG, ABS comes in a variety of colors. You can see behind me on the shelves, there is rolls and rolls. There's wood grain filament that actually has microscopic sandalwood in it. It smells amazing. There's clear plastics. There's just, it's pretty much endless. If you go online and look for those plastics, you'll see they come in a myriad of colors.
And even like glow-in-the-dark.
Glow-in-the-dark plastic, yeah.
A rubber?
There's a TPU filament, which is a rubberized filament. It has a very low shore, so you can actually bend it and flex it, and people make RC car tires out of them, or undersuits for armor.
Well, that's actually really important then when we're thinking about like bat suits and scale armor. Sometimes I know when I'm sewing like heavy duty materials, such as vinyl or faux leather, I'm looking for a bit of a stretch.
Absolutely. And arm guards, gauntlets, you can still use traditional cosplay, like using Velcro or straps to hold this stuff together. But it's the difference between using a TPU gauntlet versus a PLA gauntlet is the PLA gets a little rough and it can be a little abrasive. The TPU can bend around your skin, you can strap it, and it works great.
Well, then let's talk a little bit about actually scaling a prop or a costume piece.
Sure, absolutely.
When we talk about scaling, what is that?
Scaling is, so when you look at a 3D model, it's difficult just to look at a model and say, how big is this going to be? Because in 3D printing, a model can be this small on the screen, but you can scale it to be something that big. So there's a lot of different objects out there that you can scale. I use a software called ArmorSmith, and it's a software where you can design a mannequin that you can import your armor pieces, your 3D models, into the actual software and scale them to your avatar. Avatar being your pre-measured body or your mannequin that's made after you. So instead of the older ways of doing it, where maybe you'd wear a t-shirt and wrap it in duct tape, fill it with, paper or plastic, now we can make digital mannequins and we can scale our models directly to our persons.
So, for example, with this particular Mandalorian helmet, beautifully printed. The challenge is when I put it on my giant head. The challenge is that it's a beautiful model, beautifully printed, but I have barely enough room for my nose and my mouth.
Or the face shield that's supposed to go inside of it.
Oh yeah, I forgot. There's a shield that goes inside of this. So
visor.
This is going to be a little bit more cumbersome to wear and breathe in. So it's really important that when you're modeling or you're printing, you're preparing your model for print, that you think about the scale and your own dimensions for your own body.
Yep. So we actually did a mannequin for Philip here, and we printed him one out of PETG. This was our test print just to make sure our sizing was right in the software. And you'll see that this one fits a lot better. It's got room for the guard and padding so that you can comfortably wear it.
And so for reference, my head circumference when we measured it was 25 inches.
I believe so.
And so when I'm wearing something like this that is scaled to my head, it actually has a little bit more room that I can add padding with foam and other materials inside.
And you still have room for the visor.
And still have room for the visor. And I can breathe.
A little bit.
A little bit.
Yep.
A little bit. So this is wonderful when we're thinking about 3D prints and usability when we're out on the floor all day wearing our costumes, that it's important to have safety in mind and obviously comfort and convenience when you're designing 3D prints to be worn in cosplay. When we are considering, let's say, investing in a 3D printer, what should I look for?
There's a lot of 3D printers flooding the market in the past few years. You've got Creality, you've got Anycubic, there's Delta printers are a popular style. Me personally, I have tried and tested the Creality series. So the Ender 3s, the CR10, the CR10S Pro, most of their machines are amazing, and the Ender 3s are the most popular and probably the best bang for your buck as far as a printer goes. You don't always want to go for larger printers. Larger printers doesn't mean it's going to print faster. It just has more area, and honestly, it's going to take more time.
And now there's a lot of cosplayers who are watching who are also competitive cosplayers who create costumes for craftsmanship competition. What should we look out for? What should we be aware of that perhaps a judge might inspect during the judging process?
I think it's important to keep in mind if the files were paid for, as in you paid for the files from a website, or if you modeled them yourself. That's probably one of the first questions you should ask. The print quality, a lot of people don't understand the amount of time and effort that actually goes into these. If you bought the model and 3D printed it yourself, there's still a lot of effort that goes into that. The Spider-Man armor behind me took over 350 hours to print. So it's not just a plug-and-play machine. There's definitely a lot of nuances. There's a lot of times you have to change out rolls, inspect quality, maybe if a print failed mid-print. But there's a lot of things to consider. It's not just, did you pay for the files? Did you make the files? Did you print them yourself? Did you finish them yourself? Which are all very important questions to ask.
So the actual finishing, the preparation, finishing
Sure.
of a 3D piece is just as important, and sometimes probably even more important
Very
than
much
the
so.
actual modeling itself. Let's talk a little bit about how one can finish a 3D printed piece.
So here we've got our Princess Mononoke dagger that I designed, and it's got a lot of unsightly seam lines that were not properly aligned to the right areas. It kind of went all over the place, and we've got a crack across here. So what I generally do is you start low and kind of double your sandpaper every time. So we start with 100 grit, move up to 240 or 200, and then you start to move to your wet sanding with 400, 1000, 1500. There's a lot of resources online you can use for this. I use the paper itself. I've also got these sanding pens. They have different number grits on them. If you want, and you're getting into 3D printing, you can actually 3D print your own sanding pens that you can just cut strips of sandpaper for. These are awesome tools to get into the nooks and crannies and give yourself a little bit of oomph when you're trying to sand down. In a pinch, nail files, also a really good tool to use. Mouse are tiny drill master from Harbor Freight. You can get these tiny little Dremel tools. They just have an on and off feature, but they come with glass engraving bits, and these glass engraving bits are just like sandpaper. As long as you're not pushing too hard into these bits, the plastic won't melt around the bits. Orbital sanders and mouse sanders. These are awesome tools. You can buy the grit pads for them that are a lot stronger, all the way from the 100s to the finer grits. And again, as long as you're careful and not pressing too hard, these are an awesome tool for quickly sanding large prints. XTC 3D is a two-part epoxy. You have your hardener and you've got your epoxy itself. It's pretty much a brush-on application. It's a two-part epoxy. You mix it up in a measuring cup, you brush it on, and you wait. It makes the outside of it pretty much so you have less to worry about deformation. It makes the outside of the print stronger. There's a lot of benefits to it. The only thing I find with it is if you're using it on very fine applications, you're going to lose a little bit of quality because it kind of coats it very thick. So with a lot of sanding to come back in afterwards, it does an amazing job. It does what it says. It smooths out prints. Aqua Green is an awesome spot glazing putty that once you get a little bit out, sorry, I forgot to mix this up. Mix it up, and you can actually apply it to your seams. You can be kind of generous with it. And get a little bit off. And just go a little bit more than you need, because this will be an awesome way to sand it back down comes as a putty. You can apply it with an X-Acto knife, a popsicle stick. You just want more than you have for that seam, so just kind of make sure you apply it in there and just give it a few minutes to dry. It takes about 10-15 minutes to dry. So here we've got 100 grit sandpaper, and we are going to go over top of the acryl green that we added in. And voila. So the other option, if you didn't want to go the spot filler route, is the Rust-Oleum primer filler. I've got a little bit of flakes on it here, and you can see we've also got that same line, but I've already hit this with 2 or 3 coats of the primer filler, and I'll show you how that looks once we sand that out.
All right, well, thank you, Chase, for showing us today all of the amazing information about 3D printing, getting started in 3D printing here at RPM 3D Printing Studios. And where can we find more information about you and your company?
If you go to rpm3dprinting.com, we're going to start putting up content, and we'll start having more videos that'll help you guys out. That's what we want to do, is teach other people how to 3D print.
Because this is the way. I'm Philip Odango, and thank you for joining us today in Cosplay Central.